All right, hello everyone from my PS362 class. So I wanted to present this tutorial on Gorilla.sc, this brief tutorial on Gorilla.sc, just to maybe I didn't cover it completely in class, and some students might have been unclear or confused, so I wanted to explain a bit more. But it's important in university environment to be independent, to work on it on your own first, and then ask questions, right? Because I think that's the and learning process. If you work independently, you go through the mistakes. You made some mistakes, and this happens often in coding and programming. You make mistakes, and then you learn from it, and then um, your mistakes help you in terms of figuring out, okay, this is how I should have done it, right? So, and then once you figure out you can't figure out or you need help, I'm always help. I can't give you the direct answer, but I can give you somewhat of the answer. Or sometimes it's not really helpful for you if I give you the direct answer. I want you to enjoy the journey of learning, right? So now we have the two sample experiments we ran in class through Gorilla.sc. So maybe everyone did sign up, and then you can sign and go in and Gorilla.sc, start your free plan, and set up your own experiments. Gorilla.sc has support, also has open science, so support for if you're stuck in your experiment and designing the experiment, you can ask for help. Open science, there are actually a number of published studies now that, in terms of researchers have used Gorilla.sc for experiments for designing. Researchers have used Gorilla.sc as an online platform to test participants online in experiments. But this could also be put in the lab and then experiment, and the participant could be tested in the lab, but Gorilla.sc would be available online. So what we did, I did was design a classical Stroop experiment and a modified Stroop experiment. And you can see some other examples of sample experiments presented, which are available on Gorilla.sc. Visual search, human robot interactive experience. Haven't looked at that, but that would be kind of relevant to social psychology, which would be interesting. Semantic priming task, linguistics. So here we have the classic. So this is your task. So you can create a new task. So I'll show you. So this is my task. This is where I create the foundation of the experiment. What exactly will be in the experiment? Will there be a study phase, test phase? What exactly will the participant be doing? So the procedure, the trials. So you can create a new task builder here, build a reaction time tasks and response options, or you can have a questionnaire also built. Legacy tools refers to older versions of Gorilla in terms of the objects. There might be less number of objects like a Dropbox, but maybe in this new task builder, the Dropbox has been modified and it has been improved on how it appears on the online platform. So what I like about Gorilla is they continue, it's open source. I mean, they continue keeping updating it in terms of the software. You don't have to download anything like CyclePy, you have to download something or ePrime, but it's already available to you online and they're updating it constantly. The one thing though with Gorilla.sc, I know it's I need to have a good Wi-Fi connection to access online. Obviously, you can't have a standalone application of Gorilla.sc. And so you have to be connected online. Another aspect is for this Gorilla.sc, it hasn't really, I mean, it is becoming very fast, major platform now being used in research, but it's not as, still not in the level of CyclePy or ePrime in terms of recognition. But they're constantly updating it in terms of the features. So here you have a experimental classical Stroop task and modified Stroop task. So here's the sample classical Stroop test that I set up. And obviously, you know about the Stroop task, you get a word. It can be either in congruent or incongruent. So for example, red in red color, and the participant has to indicate red as the ink color of the word. In an incongruent trial, what you will see is that the word it does not match with the color. So for example, red would be in green, and the participant has to say green or press G on the keyboard to indicate green for the word. And so obviously what researchers in the Stroop, I think it was 1967, he did it for his PhD dissertation, I believe. But what he showed was that there was less time, participants took less time to indicate if it was um, red on red, red ink, versus when it was green on red ink, red word, green for red word, so G. And the reason is, he might have mentioned the mechanism behind it, obviously did. Uh, and it was inhibition idea the participant couldn't inhibit the, uh, there are two streams, the ink and then the word itself. So the word red is in green, but red is red, right? So it's automatic, and then that's counteracting the green. So e- there's counteracting streams of information, and you're trying to pay attention to one stream, and you have to inhibit the other, which is automatic. So that's the inhibition theory. And the other, there are other theories of the Stroop effect, and you can actually do a search on it in terms of various theories of the Stroop effect. Now, so you have the screen, the instructions here, the famous Stroop experiment, and that's important. So displays is an important part of an experiment here, right? The display, you have instructions, which is a screen over here, and then the trial. So what's going to happen? There are many trials, right? But this is the basic structure of a trial. You have the word on the screen, fixation, and then the screen. So if I want to go to the word, and you'll notice that to get the word, I don't type it in over here like in text, but I have to bind it to, so I'll put it in edit mode here. So this is allows me to edit my objects in here. So the word, but let's go to the spreadsheet here. So how many trials do we have? So we have the instructions, and this spreadsheet is going to be very important for your lab 3 when you're designing your experiment, or and then I might have the experiment already set up, but in case you want to design your own experiment, it's the same thing. You'll need to have a spreadsheet. So here you have the trial, the word, the color. So I have an RGB values. This way enabled me to have the red in green, right? So 02550, and you have the correct response, G, and it's incongruent. So red, the word in green, right? So that's incongruent trial. Red in red, 25500, comma 00, comma 0. So congruent, and then the correct response is red. So there are only a few trials, but in a typical Stroop trial task, there would be 100 or more trials. Spreadsheet. And then what you're measuring, obviously, is the reaction time. And this is a good thing about Gorilla, that it allows you to measure reaction time. Although there has been research suggesting that with online platforms, which might be an issue with Gorilla.sc, but there actually been a publication suggesting that reaction time is not different, not distinctly, significantly different from that of the standalone application. So for example, PsychoPy and E prime would give you reaction time for your response. Would that reaction time be the same if you're running the experiment on Gorilla.sc? And some might argue that it will be significantly different, or others would argue be significantly, it won't be significantly different. So, but there has been a publication by the Gorilla, the SC platform, who have looked at this, and they concluded that reaction time was similar to standalone platforms, I believe. So here you have the spreadsheet, and then you have the stimuli. We don't have any stimuli because these are words, but you could put in images here, over here. So I did that for my PS360. I mean, we will probably have one of the experiments will have images in it, like pictures of faces from a database. So here's the trial, word on screen, text over here, the name. But it would have been better if I just said Stroop word, just to make it clear. Text size is 30, centered and middle. The color. Uh, so here it's connecting again to a column in the spreadsheet, and it's the word, right? And then here it's connecting to a column in the spreadsheet, which is color, right? I can then go my displays again, and then you see end experiment. This is a markdown text over here where I enter in a text. And this is another good thing about Gorilla.sc. We can use HTML. So here, for example, or CSS, I believe. You can increase the font size of this. So here you can see the font size increases. I can change the spacing, be on, be on, and then I can enter, great, having here, what is space, in my experiment. And you can basically change how the instructions are presented on the screen. And the backend for these objects is JavaScript, but I haven't really looked into more into this. I will look more into the use of JavaScript, but it's always good to understand the code also. I mean, what if you wanted to create your own objects? That would be interesting in an online platform, and hopefully Gorilla.sc enables users in the future to start creating their own objects. Now, that would be interesting. So we can have a Dropbox. You can have a Dropbox. You can have audio. In my other study, for example, in the 2024 published study in Quarterly Journal of Experimental Psychology, I have pictures and sounds presented, and the I mean, I had pictures and sounds presented. I would have the image here, object, and I can also have the audio, but the audio would link up to an MP3 file, right? Or AVI file, which were all in this stimuli. So you can add sounds here, add pictures or other types of stimuli, like faces, pictures of faces into here also. Audio clip, audio recording. You can change the length of the image on the screen also by using a fixation timing over here. So fixation timing, although it's called fixation, fixation timing can be linked to the picture or the sound in terms of the duration. Right? Display spreadsheet. Let's go to stimuli displays over here. What's this? And you can see Stroop word linked here, color, and then the keyboard response. So basically keyboard, I can add a keyboard here, done. And then I will add my mappings to the word. Let's see, so let's say you wanted green, the key for green, and then you'll just like keyboard. This is what the participant said in terms of the response. Obviously, green. This is what you want to collect in terms of the responses from the participant. R is for red. Obviously, make it more easier for just saying R, G, Y, B. But Stroop has more than 4 colors, I believe. I wonder if researchers have looked at more than just R, G, Y, and B, but other colors and effect on that. So that was the classic Stroop. I can go to the experiment. So if I go to experiments here, so this is my task, the foundation or the backbone of the experiment. And I have my experiment here. Click on it. And this is the design. So you can see start, and then you have uh, the, um, so if I did this editing, and then I would add new node, and then I can add my task here, and I can then select a task from here, right? I can also add, well, randomizer, branch order. These are ways for counterbalancing to occur. I can add a questionnaire. And, the, and these are other tools on the design. So you can see this could also been included. Counterbalance is right here. And then you have delay, repeat, quota, allocator. So these are some interesting other objects or nodes you could add. Oh, well, not yeah, nodes you could add in. And then, well, here I'm not really going to commit my changes because I'm satisfied with my experiment already. So if I wanted to change it, if I made some changes in my task, and update all nodes here. Right. Recruitment. In terms of Gorilla.sc, if you were running the experiment, you could, for example, change the recruitment target. So let's say you were testing 100 participants, then you would have to buy tokens, right? My account, add tokens. And with Gorilla.sc, you do have to buy tokens to it's an online platform in order to test participants. Add participants here, browse, and you can spreadsheet, public ID name, Gmail. Well, obviously, we'll just have the public ID. That's the only thing which will include it in the spreadsheet, and you upload it. And once you upload it, you can see in participants all the participant IDs included. Participant login. So this is the login. So change recruitment link. So this is the supervised. And then all the participant does is they will go to this link over here and enter it. And then they would add in their ID, and then the experiment would start. Right? And the participants will be populated over here. And this is where you would download the experiment data. But since there are no experiments, we'll just run the experiment and then download it as you did before. So classical Stroop over here, and then I'll preview the experiment. And I'm just showing you this experiment that implements the famous Stroop task. When a word appears, the color of the gold can be red or blue, yellow, and so forth. Proceed, next. There you go. And now I have to click, click a key on the keyboard, right? So green, let me see how fast I am. Yellow, red, blue, yellow. Sorry, it's late right now, but trying to be as fast as possible. Age is a factor, right? Multitasking could be an issue too. And then I can download this data. And so in the next video, I'll talk about how to clean the data and then uh, put it in just for analysis. Let's go back. Now, the other experiment was the modified Stroop. So what was my modified Stroop? When we do, when any researcher obviously wants to design a new experiment, they look at past research and identifies some limitations in past research and then improve on that research, like adding in some duration aspect, but they need to explain why, or adding in stimuli, or changing the instructions, or changing the entire experiment design. So there has to be a reason for doing this, but I think some research follows this pathway, but you need to explain why. So in terms of my modified Stroop, what I added in was the duration was changed in terms of the length of time the word was presented. So let's say the word on the screen was presented for 2000 milliseconds versus 4000 milliseconds. Does that have an effect on Stroop, on the Stroop effect? And if the Stroop is mediated by attention, and your ability to inhibit distracting information. Then that means duration should not have an effect. Because how long you are able, I mean, duration should have an effect. I mean, how long the word is on the screen, and if you're forced to respond as quickly as possible, then you're less likely to inhibit the distractor, right? So if there's a time pressure, 2000 versus 4000, so you're more likely to have participants do worse on the incongruent compared to the congruent trials in the 2000 duration compared to the 4000 millisecond duration for the incongruent compared to the congruent, right? Because now you have less of a time pressure on the participant. So you have this trial, word and color, so I added in duration. And so you have two independent variables which are being manipulated, the congruency and the duration. And we'll talk about it in JASP about the statistical analysis. JASP is kind of very much similar to SPSS, but it's open source and it's continuously being added, updated, and it's free. So that's that part. The task itself is here. So let me show you the spreadsheet, right? And then spreadsheet is very important. This is going to be in lab 1 and lab 2 and lab 3. You'll need this to design a spreadsheet like for your own experiment, or if you want to improve on an experiment. Your own experiment, if you want to design your own experiment, perhaps it's also psychology or something you want to do on your thesis or something else. Okay, good. And I'll help you out. Word on screen, red. Now notice the word is linked to a column in the, so let me put in edit mode so I can modify, show you what I'm talking about. So the word on the screen, so the text here, and then I bind it to the column in the spreadsheet, which is the word, right? And I can bind it to the color also. So this is bound to the color column, and this is the RGB value. So it's red, the word red and green. Obviously, if I had it, not the RGB, but just green, I don't think it would have been detected in Gorilla.sc in terms of red being green. So the RGB value was used, linked to the word itself. So each trial, as you see, you have first this trial, then that trial, then that, and it'll follow in a sequence. But I added this column here called random. I named it randomized trials. So I could randomize these trials. And so that's beneficial in Gorilla. I haven't looked at counterbalancing that much. So you can see randomizing, randomized order, randomized block order. You can find some more examples in our spreadsheet randomization guide. So this is a helpful information on Gorilla.sc on various objects. So if I wanted to add component, randomize trials, and then I can choose which column I want to randomize in my trials. So this randomized trials, right? And then once I make my changes, I can commit over here. So let's go back to the modified Stroop. Same thing, you have this node over here, and then you link them up together with this arrow. But let me see. I'll just edit this and I'll show you something. I'll edit it, I'll remove it, remove, okay. Now watch, I add this mode over here, my task, and the practice sample Stroop task with the duration, I move it over here, and then I connect it with the arrows, right? So now you see the sequence forming up. Recruitment, participants, data, and let's run this in preview mode. It's a design part. And I'll run it in preview experiment. And here we go. So this is an experiment. So this next button, I should have put it down here. When a word appears on the screen, your task is to indicate the color of the word. The color of the word can be red or blue. Or, uh, so this should have been green. Red or blue or yellow or green. When the word appears, indicate the color of the word by pressing red R for red, or G for green, or B for blue, or Y for yellow. Please note you need to respond as quickly as possible. To proceed to the test trials, press the next. So press next. And so now I have to be as quick as possible for some of the trials. Yellow, red, and blue, and green. I could have reduced it to 1 second. That'd be interesting. Yellow, red, blue, yellow. Okay. And then I can download my data. And so when you download the data, it will be in raw form. So in the next video, I will talk about cleaning the raw data, which I discussed already in class. And then you can import it into JASP, or statistical analysis. In this case, we would be doing a two-way repeated measures ANOVA because we have two factors, the congruency, if it's incongruent or congruent, and the duration of the presentation of the Stroop, and then we're looking at response time. All right, thank you everyone. I hope your classes are going well. And that's about it for the video. If you have any questions, feel free to ask me in class, or we can go through email or to my office hours. Thank you.